So now today we are going to discuss the equivalent weight. Equivalent weight. So in equivalent weight, I told you yesterday that equivalent weight is what? It is molecular weight. Sorry, atomic weight divided by the valency of particular element. Okay. So this is the first basic thing that you have to understand. Okay, this one. So here what we are going to discuss is various numerical based on equivalent weight and the concept of you know titration. Some concept of titration are there which is based on the equivalent weight. Okay, this one. So let's start with this. So this is the concept we did yesterday. Equivalent weight is your atomic weight divided by the valence. Okay, now there are various categories. Okay, various categories of molecules. Okay, various categories of molecules in which equivalent weight is different. Okay, this one. Now you see, suppose okay, for acids. Okay, for acids, what is equivalent weight? Equivalent weight is equal to molecular weight of acid divided by number of protons given by 1 mole acid. Okay, this is the this. Now for example, HCl. Yes, that is also called as basis. So HCl, 1 mole of HCl will give 1 mole of proton plus chloride ion. So equivalent weight will be, for HCl the molecular weight is your 36.5 divided by 1, because 1 mole acid is producing 1 mole proton. So equivalent weight is same as that of molecular weight, no problem. Okay. For H2SO4, it is 2H plus ion. Okay, 2H plus ion and sulfate ion. Okay, so here equivalent weight is your 98 divided by 2, because 2 protons are released by 1 mole H2. For H3PO4, there are 3 protons plus phosphate ion. So here equivalent weight is equal to uh, phosphorus is 31, 16 for the 64 plus 31 and this 3, so 3 was 7, 8 and 98. Okay, so here also it is 98 divided by 3, because 3 protons are released. Okay, so there are various acids. Okay, so for acid you have to see how many protons are released. Okay, so that is molecular weight of the acid divided by the number of protons released. Now for the base, okay, so for the base it is same. For base it is equivalent weight is equal to sorry, molecular weight divided by number of OH ions. Basicity is shown by the OH negative ions. Number of OH ion released by 1 mole acid. Okay, 1 mole acid. That is your equivalent weight for base. Sorry, one, that is your for base. Sorry, that is your base. Okay, so this is it. Now, for example, if we take say NaOH, NaOH releases only 1 mole proton. Oh, sorry, 1 mole hydroxyl ion. That is the hydroxyl ion. So it will be equivalent weight is equal to 40 divided by 1. For calcium hydroxide, calcium hydroxide is called as slaked lime. Okay, slaked lime, sometimes called as lime water. Lot of categories are there. So it is calcium 2 plus 2 OH ion. Equivalent weight will be 40 plus 17 into 34. So it will be 74 divided by 2, because there are 2 OH ions which are released. Yeah, this one. So there are various categories. Okay, so you understood the basic concept there. Okay, understood the basic concept. For now, this is the important one for salt. Okay, for salts. Now, salts we don't study in the 9th 10th class. Okay, we don't study salts in the 9th 10th class basically. Okay, so there are two types of salts. Okay, two types of salts. Okay, one type you see in which no H plus ion can be donated. There is no H plus ion which can be donated. For example, sodium sulfate. Okay, sodium nitrate, sodium nitrate, then say NaCl, like this. There is no replaceable hydrogen. Okay. In this category, the equivalent weight is equal to molecular weight of salt divided by total positive charge. Okay, total positive charge in salt. So for example, if you take sodium sulfate, so its equivalent weight will be molecular weight of sodium sulfate divided by 2, because there are two positive charge, 2 sodium. Okay, sodium is positively charged. For example, now we take aluminium sulfate, Al2SO4 whole thrice. Okay, now understand that it, okay, in the dissociation, when we were counting the total number of ions, I told you dissociate as 2Al plus 3 plus 3 sulfate ion. So equivalent weight is equal to molecular weight of Al2SO4 whole thrice divided by 6. Why? Because two aluminium plus 3 are there. Each aluminium has plus 3 charge, so 2 aluminium plus 3 has plus 6 charge, so divided by 6. Okay, same thing you can take for the negative charge, because negative positive charge is equal and the molecule is neutral. So there are 6 negative charges, so you have to divide it by 6. So that is your equivalent weight for the salt which don't have any replaceable hydrogen. Now another category of salt is which have replaceable hydrogen. For example, NaHSO4 or NaH2PO4. Okay, this salt you will study in ionic equilibrium, that is your fifth, sixth chapter. Okay, there I will discuss. Here I am not discussing because that is a very, that's all together we will go on a different track. Okay, now these two salt has replaceable hydrogen. So if there is a replaceable hydrogen, okay, then number of hydrogen are divided. Okay, here suppose you take NaHSO4, equivalent weight of NaHSO4. Okay, there is one replaceable hydrogen, releasable hydrogen you can say. Okay, one I should write in an easy language. One hydrogen, one H plus ion can be released. Okay, in NaH2PO4, 2 H plus ion can be released. Okay, this probably you don't know, but don't worry about that one. That is just for information. Okay, questions will not come on this, but you should know at least the definition. So equivalent weight, or to write this, equivalent weight for NaHSO4 is equal to molecular weight of NaHSO4 divided by 1. Okay, equivalent weight for NaH2PO4 is your molecular weight of NaH2PO4 divided by 2, because there are two replaceable atoms. Okay, this concept you have to just learn the definition. No numerical comes on this. There is no numerical. Then comes on third category C. Yes, I should not write. I should write third one. Fourth actually it is. So fourth one is equivalent weight in oxides. Okay, and that is the most important. 99% question comes on this concept, equivalent weight in the oxides. Okay, and we will do the detailed one here. Now equivalent weight in the oxide means what? Okay, uh, now I told you that the equivalent, first you see equivalent weight of the equivalent weight, what is it, of oxygen. How much is the equivalent weight of oxygen? Aparajita? Anybody listening or not? What is the equivalent weight of oxygen? Equivalent weight of oxygen is what? Array last 8. Last time I told you. This PDF also. Atomic weight divided by the valency. So atomic weight is 16. 16 divided by 2. So that is your 8. So equivalent weight of oxygen is 8. One thing you have to remember. Now in the definition, okay. So equivalent weight of oxides. Now you say there are various oxides. Suppose we can take this sodium oxide, okay, calcium oxide, say aluminium oxide, iron oxide, okay. Then we can take carbon dioxide, then we can take P2O5, okay, then sulfur trioxide. So there are various oxides, okay, there are various oxides, and these are the metals or non-metal, whatever. So these are the elements: sulfur, phosphorus, carbon, aluminium, and all that, which are connected in this manner. You can take this one also, xenon, chlorine oxide, this one. Okay, so I told you last time, okay, I told you last time that what is the weight, what is the equivalent weight of iron. I told you last time about the iron oxide, this. So whatever is the molecular atomic weight, it is divided by the valency. Okay, that is the basic concept, that is divided by the valency. Okay, so we will see all the aspect of this equivalent weight in the oxides. So first tell me, what is the valency of sodium? What is the valency of sodium? 1. Valency of calcium is 2. Okay, valency of aluminium is 3. Here valency of iron is 3. Iron has valency 2 and 3 both. Here we are taking 3. Valency of carbon is 4. Valency of phosphorus, Here it is 5. It has also valency 3. Valency of sulfur is 6. Okay. Valency of chlorine is 7. Any doubt in that one? Okay. Now, if suppose someone asks you that find what is the equivalent weight of sodium in sodium oxide. Okay. So here the valency of sodium is 1. We know that. Okay. Valency of sodium is 1. So equivalent weight will be, so equivalent weight is equal to 23 by 1. No problem in that. Okay. Similarly in calcium oxide, equivalent weight is equivalent weight of calcium. Okay. So equivalent weight of calcium. So what is the equivalent weight of calcium? It is 40 divided by 2. Atomic weight of calcium is 40 divided by 2. Okay. Similarly, you can take aluminium, Al2O3. Okay. Equivalent weight of aluminium is 27 by 3. 27 is the atomic weight of the aluminium. Okay, got it? Everybody is getting this one? Yes or no? Okay. Now suppose I write a hypothetical molecule MXOY. Okay, MXO. Here, okay. This one. Now MXOY. What is the equivalent weight of M? Equivalent weight of M is what? Okay. If atomic weight of M is M. This is the question. This is the example. M MO4. What is this? Huh. M by 4. Okay. Patel Yash is not here. Okay. So now understand this. First you have to see this one. Valency part. You have to see the valency part. Okay, this one. Now if you see the valency part, okay, this is. So here the valency you can see. Can you see the valency? Okay. So for sodium it is 1, calcium 2, aluminium 3, and so forth. So what is the valency of this metal M? Metal or element M? What is the valency? X is a number. Suppose this is the number, this is the number. So in terms of X and Y, what is the valency? No, no. Now you see this one. Calcium oxide, it is 1 1. Valency is 2. Okay. Are you getting it? then 2 and 3. Now aluminum valency is 3. Aluminum valency is 3. And here we have 2 and 3. Iron valency is 3. We have 2 and 3. Carbon valency is 4. We have only 2. Phosphorus valency is 5. We have 2 and 5. Sulfur valency is 6. We have only 3. Chlorine valency is 7. We have 2 and 7. So what you can infer from this? Okay. So let's take P2O5. Okay. So P2O5, or I can write MXOY. So what is the valency of phosphorus? That is your 5. Okay, 5 valence. So this is the 5. So valency is 5 into 2 divided by this 2. Okay, so it will come as 5. Chlorine valency is 7 here. Chlorine valency is 7. So here valency is 7 into 2 divided by 2 here. Okay, this one. For carbon dioxide, here it is 1. Valency of carbon is 4. We all know that. So this number 2 into 2 divided by this number 1. Okay. So what basically you have to do to find valency, you have to take this number 5, here it is 5, multiply it by 2 and divide by this number. Okay, here the number is 7, you have to take 7, multiply it by 2 and then again divide it by 2. 2 is this number. Then you have to take this number 2, multiply it by 2 and divide by this number. Okay, for example, Na2O, sodium has 8 by X. Array, you are not getting. It is Y. It is Y. That is Y. 4 is this here. This is 4. So sodium oxide. So this is number 1. This is number 1. So you have to multiply 1 into 2. And then you have to divide by this number, which is 2. So that will come as 1. Okay. So what is the valency here? For MXOY, what is the valency? Anybody can tell. Teeth. Aparajita. 2y upon x. So that is the valency. Okay. So okay. So I said you to find the equivalent weight of M. So what is the equivalent weight of M? That is your M. M is the atomic weight. I'm just taking M as the atomic weight divided by 2y by x. Got it? So this is it. Why? Because that is so much easy. You have to understand the valency concept there. Okay. Yes. Uh, this oxygen. Oxygen is the second element because we are talking only about the oxides. Only about the oxides here we are talking. What? That we will do in that we will do because I will teach you for each and every one. You should know what is there. Okay, if both are hypothetical, it is very difficult to calculate. For oxygen, It sometime it is correct, sometime it is not, because we don't know the valency of this metal. It is, you will learn eventually, because we will do whole lot of questions. So have you understood the concept of valency, concept of the equivalent weight in terms of valency? Okay, everybody. Now there is another concept of okay. So in metal oxides or any oxides, suppose for any oxide, there is another definition: equivalent weight of metal or element in its oxide is the weight which is bonded to 8 grams oxygen. Okay, this is another definition. Okay, this is another definition. Okay. And there are a whole lot of numericals based on this definition. Have you understood this one? Equivalent weight of metal or element, or, most of the time it is metal, in its oxide is the weight which is bonded to 8 gram of oxygen. So 8 gram oxygen, wherever it is connected, it shows its equivalent weight. For example, in say for example, let's take this calcium oxide. Okay, any example you can take. So calcium oxide, now weight of calcium is 40. So 40 gram of calcium is bonded to, what is the weight of oxygen here? 16 gram. Okay. So whatever is the weight of calcium which is bonded to 8 gram of oxygen, that is your 20 gram. Okay, so that is your equivalent weight. So 20 gram is equivalent weight. Also, you know that valency of calcium is 2, so by valency point of view also you can do that. 40 divided by 2 is 20. Okay, both are correct. Both are correct. Okay, so this is the one of the aspect. One of the aspect. For example, again, if you take Fe2O3, Fe2O3. Now, weight of iron is 56. So, two iron, you can see two iron are bonded to 3 oxygen. So, 2 iron are bonded to 3 oxygen, or we can say 2 into 56 gram of iron is bonded to 3 into 16 gram of oxygen. Okay. Then whatever weight of iron which is connected to 8 gram oxygen is the equivalent weight. Equivalent weight. So whatever is the weight which is connected to this is the equivalent weight. So what will be the equivalent weight? It will be, okay. So equivalent weight will be how much? 56 divided by 3. So 3, 16 3s are 48. 16 4 the 64. 16 3s are 48 divided by 48. So it will be 8. 16 6 and 96, or 16.7. 18, that is 50. So it divided by 3 into 16. So it is 56 by 3. It will be 56 by 3 last. 18.6. So it is 18.6. Okay, so this is, and also valency of iron is 3 here. So again you can take it by valency, 56 by 3. So both will give the same result. Both will give the same result. Okay, this is one of the aspect. Okay, another aspect that is very important here is that equivalent weight of Fe2O3. Okay, here in Fe2O3 we calculate the equivalent weight of iron. Okay, this is your equivalent weight of iron Fe. If we have to calculate the total equivalent weight, okay, we have to calculate the total equivalent weight of Fe2O3. So we have to calculate the weight of Fe2O3. Suppose, what is the weight of Fe2O3? It will be 56 into 2 plus 16 3 the 48. So that is your molecular weight. So it will become 2 6 are 12. So that is 112 plus 48. So that will be 162. Oh, sorry, it's 10. Sorry, 160. So that is your total weight. Okay. And then this 160 is divided by 6. 160 divided by 6. So that will be okay, 26.66. Okay, why I divided it by 6? Because there are two iron. Okay, I told you above, two iron are there which have plus 3 means 3 valency are there. So total that is 6. So 160 divided by this one. Again we can also write is again you can see that what is the equivalent weight of iron in Fe2O3, that is your 80.67 or 80.66. What is the equivalent weight of oxygen? Okay, equivalent weight of iron is in this Fe2O3 is 18.66666. Equivalent weight of oxygen is what? 8. And when you add this and this, so what we will get? 26.6. Okay, so equivalent weight of Fe2O3 is equal to 18.666 plus 8. So that will become 26.666. Okay, so here what we can say, equivalent weight of Fe2O3 is equal to equivalent weight of iron plus equivalent weight of oxygen. So that is your this weight, equivalent weight of Fe2O3. So that is your 26.66 is the equivalent weight that we calculated. Okay, and then is this one. So that is your equivalent weight of iron, equivalent weight of oxygen. Got it? So this is the another concept of equivalent weight. Okay, and this will be applicable to most of the compounds here. Okay, have you understood this one? Got it? Okay. Now let's take some. Okay, so that is where we started. Okay. first thing you have to understand the concept of valency here. Okay, what is valency, mxoy, how it is treated. Okay, this one. Then you have to see the definition. Equivalent weight of metal or element, it's an oxide. Okay, is the weight which is bonded to 8 grams of oxygen. So that will again give the same result. Okay. Then the last one is this one. Okay, equivalent weight of the oxide is the equivalent weight of metal plus equivalent weight of oxygen. So this is another concept. Got it? Now let's take some question. Okay, for oxides. There are more questions. Okay, now let's take one of the question. Equivalent weight of divalent metal is 31.5. So 31.5. What is the weight of single metal atom? Now divalent means its valency is 2. Okay. Okay. 63 gram. Hello. What is the unit? Yes. A. That is correct. Okay, so that is the correct answer. That you have to just double it. Okay, you will get the answer. Okay, then oh gosh. Okay. Let's take another question. So this is Just you have to multiply 31.5 into 2. Okay, so that will become 63 AMU. Okay, single atom. Now let's take another question. In MO2 there is some metal oxide. Okay. Equivalent weight of metal is 9. Okay. What is atomic weight? Okay. What is atomic weight? Atomic weight of metal, you have to say. Okay. In MO2 equivalent weight of metal is 9. What is the atomic weight of metal? Metal means take an element of anything you can take. M I just write to make it E. I can't write because E is your equivalent weight, so it is a bit confusing. E is for element also. Just take anything: carbon, sulfur, sodium, potassium, calcium, anything. Okay. Yes, Aditya, 6 AMU. No, atomic weight is in grams. 66. 66. 36. Yeah, 36 is the correct answer. 36 is the correct answer. Atomic weight is in grams. So here, what is the valency? Valency is your 4. I told you how to calculate the valency. Okay, there, if you have not observed, so it is less like carbon dioxide. Okay, MO2 is just like carbon dioxide. So valency is 4, 2 into 2. So this is 2, you have to multiply it by 2 and divide by this number 1. So here valency will be 4. So both carbon and this some element has valency 4. That is a hypothetical one. So its valency is 4. So valency of M is 4. Okay, valency of M is 4. Got it? So here, now equivalent weight is equal to atomic weight divided by valency. Equivalent weight is how much? It is your 9. Atomic weight divided by 4 is the valency. So atomic weight is 36 grams. Okay, that is a so this is a simple question. Okay, this one. Got it? Now let's take another question. In metal oxide, in a metal oxide, 45% is the weight of metal. Okay, 45% is the weight of metal. What is equivalent weight of metal? Okay, this is the question. Yes, Aditya, what is the answer? Yes, any answer? Yes, Aparajita. Okay, okay. It is already 5. I have to discuss chlorine, hydrogen, carbonate. Okay, the 659. Let's solve it now. So, if okay, metal weight is 45%, what is the oxygen weight? 6.5 here. What is the oxygen weight? 45. Suppose you take 100 gram of metal. Yes, so that is your 55 gram. So 45 gram of metal is bonded to 55 gram of oxygen. Okay, that you all agree upon. Aditya Prince, Teerth. Okay, so 45 is bonded to 55 gram of oxygen. So whatever weight of metal which is bonded to 8 gram is the equivalent weight, isn't it? Okay, so equivalent weight is your 45 into 8 divided by 55. Okay, this is the equivalent weight. Now you can calculate this and get the answer. Any doubt you can ask. Okay, bar will come. Okay, so this is how we solve for metal oxides. Most of the question are from metal oxides. Okay. Now next, I have to take for hydrogen. equivalent weight for hydrogen. Equivalent weight for hydrogen. Hydrogens mean uh, for hydrogen released, I should write hydrogen released. Okay. So when I say hydrogen released, always remember that H2. Okay, H2 means uh, two valency of metal. No, I should write like this. Okay, suppose there is sodium metal. Okay, sodium metal. Now take example. Reacts with HCl. Okay, so it will give NaCl plus hydrogen atom. Okay, now hydrogen atom doesn't remain as such because it is very reactive. Okay, so it suddenly immediately it reacts with another hydrogen atom. Okay, they both combine to give H2. So in that process we need two sodium atom to react with two HCl to give hydrogen gas. Okay, 1 mole hydrogen gas. Okay, 1 mole hydrogen gas. Got it? So 2 mole sodium, if we add all these things, 2 sodium plus 2 HCl to give 2 NaCl plus this hydrogen and hydrogen I am writing H2. Okay, so 1 H2, this one. Okay, got it? Because sodium has valency 1. Sodium has valency 1. So each valency will release hydrogen atom, one hydrogen atom. Okay, so we need two sodium atom to release two hydrogen atom to give H2. In the case of calcium, take the case of calcium. Now calcium has two valency, so it directly reacts with 2 HCl to give calcium chloride CaCl2, and these two hydrogen are released as hydrogen gas. So one calcium and one hydrogen gas, 1 mole hydrogen gas. So okay, got it? So here if I take in case of aluminium, aluminium has 3 valency. So 3 HCl, so it will give AlCl3 plus 3, okay, hydrogen, this hydrogen atom will be 3. So 3 hydrogen atom means 1.5 of this. So I will write 3 by 2 of hydrogen. Are you getting? Okay, 1.5. Or you can write 2 aluminium will give how many? 3 hydrogen molecules. Okay, 2 aluminium. Now from this, oh, battery gone. hot tempered here. Why it is not charging? Hello. Okay, sorry for the interruption. Some problem with the charging happened. Are you people there? Okay. So what I was saying that if you see sodium, okay, one sodium is producing one hydrogen atom, okay, this one, and one hydrogen atom is H2. So that is only this half of the H2 is produced. So we need two sodium atom to produce two H2. Okay. So if there is a statement that 1 mole sodium, suppose I can write like this also, 1 mole sodium will produce half mole of hydrogen. Okay, half mole of hydrogen. Half mole of hydrogen means that we need 2 sodium to produce 1 mole of hydrogen. That's it. Okay. Calcium means 1 mole of hydrogen. Got it. So just for the sake of understanding, I am writing valency and moles of hydrogen. Okay, if valency is 1, half mole hydrogen is produced. If valency is 2, 1 mole hydrogen is produced. Okay, if valency is 3, 1.5 mole hydrogen is produced. Okay, valency is 4, 2 mole hydrogen is produced. Okay, that's how you will in your module, in the books, in the previous year paper, you will see that they will give you the moles of hydrogen released and they ask you the equivalent weight. Okay, this is the concept. So when you see how many moles of hydrogen released, you can easily infer what is the valency which is there. Okay, what is the valency which is there? Okay, got it. So this is the concept only. So in hydrogen released, okay, this is the only concept, equivalent weight. So that is the basically this concept is there, hydrogen released. Okay, this is the concept. If you remember this, all your questions will be solved. Okay, so valency and hydrogen released, you can, after finding the valency, you can find the equivalent weight. We will do numericals on this. Okay, because I due to this charging problem, lot of time is wasted. Got it. So last, okay, it's 7-11. Last I want to tell you about the, not the last, it's carbonate and chlorides which are remaining. Equivalent weight for chlorides. Okay, that is very simple. Okay, now chlorine Cl atom, its valency is 1. Always remember, valency is 1. For example, sodium chloride, sodium 1 valency, chlorine 1 valency. Calcium chloride, calcium has 2 valency, so we need 2 chlorine. Okay. Aluminium chloride, aluminium has 3 valency, so we need 3 chlorine to satisfy it. Okay, so according to the definition, okay, equivalent weight in chlorides, equivalent weight in chlorides is the weight which is bonded to 35.5 gram chlorine, which is bonded to 35.5 gram chlorine. Why 35.5 gram chlorine? Because valency of chlorine is 1, atomic weight of chlorine is 35.5, so equivalent weight of chlorine is also 35.5 because its valency is 1. Valency is 1, so equivalent weight will be equal to atomic weight. Okay, that is same as that of oxide. Okay, in oxygen, what is the weight? It is 8 gram because the equivalent weight of oxygen is 8. So according to the definition, okay, what we did was that sorry, where I wrote that one. Okay, this one. Equivalent weight of metal or element in its oxide is the weight which is bonded to 8 gram of oxygen. Equivalent weight of oxygen is 8 gram. So that's why we take 8 gram of oxygen, and that corresponds to the equivalent weight. Now here in the case of chlorine, it is 35.5 gram because equivalent weight of chlorine is 35.5 gram. So we take the weight of metal which is connected to the 35.5 gram. Okay, everything you have to do is same. Calculation aspect will be just like your oxides. Okay, last is your this carbonates. Okay, equivalent weights for carbonates. Equivalent weight in carbonates. Okay, now what is carbonate? Carbonate is this CO3 minus 2. Valency is equal to 2. Okay, for example, you have heard about sodium carbonate. What is the common name of sodium carbonate? Washing soda. Okay, it is washing soda. Okay, calcium carbonate is there, various other carbonates are there. Okay, so sodium has 2 valency, carbonate sodium has 1 valency, carbonate has 2 valency, so 2 is there and 1. Okay, so again the, okay, so weight of carbonate, what is the weight of carbonate? It is 60 grams. Okay, 12 gram carbon plus 48 gram oxygen. Equivalent weight of carbonate will be 30 gram. Okay, so according to definition, same definition we will use. Okay, in carbonates, okay, the equivalent weight of metal or element, any element, okay, is the weight which is bonded to 30-gram carbonate. Okay, 30-gram carbonate. So that is the equivalent weight for the carbonates. Okay. So now we will do tomorrow because the time is not there. Tomorrow we will do numerical based on this hydrogen, fluorides and carbonates. Okay. Then if when we will finish, you can find the equivalent weight for anything. Okay, for anything, for any molecule. Okay. So we will do whole lot of question based on this one. Okay. So now you can leave. Huh? 5. Huh, I will send you on PDF. Yeah. Okay, now you can leave the meeting.